Hey, math friends. So our learning target today is that I can identify rational and irrational numbers. So we're going to talk about what that means to be rational in terms of a number. We know what it means to be rational, like a rational person, but what does it mean to be a rational number? So by definition, a rational number is a number that can be written as a quotient of two integers. Quotient really means it is just a fraction. So it says right here, it's just a fraction. So when we're talking about that, it's a quotient or a ratio. All rational numbers, by definition, can be written as a fraction. Now, sometimes it doesn't look like a fraction like right out of the gate. Maybe it's a decimal that's converted to a fraction. Maybe it's an integer that's converted to a fraction. Maybe it's a fraction and still a fraction. Maybe it's a whole number, which is also an integer, as we've learned, that's converted to a fraction. So if we can somehow manipulate it into a fraction, we have a rational number. So ideas of what are rational numbers and what are not rational numbers. So rational numbers are any number that can be a fraction. So 1/2. We could also say 50 cents. That can be converted into a fraction of 1/2. We could also say 3 1/4, which can be 3.25, which is the same thing as 13/4. Rational. We can also talk about the square root of 25. Why? Well, the square root of 25 is a perfect square. That makes a perfect square of 25. That has a side length of 5, and that can be manipulated into a fraction. Those are all rational. Anything that can be written as a fraction is rational. So the other thing that we're going to talk about is irrational. So irrational then is by default the things that cannot be written as a fraction. So something like pi, super well known, value 3.1415, ... no pattern, and it goes until infinity. Irrational. Another super well-known category of irrational numbers are the square root of things that are yucky. What I mean by that? Rectangles. So things that are not squares. So for example, the square root of 5. That's a 1 times 5 rectangle. The square root of 8. Is that a square? No, that's a rectangle. That's a 1 times 8 rectangle or a 2 times 4 rectangle. So those are the things that are considered irrational. Yucky square roots and pi. Essentially, those are the two main ones. So we're really talking about things that are no pattern at all and things that do not stop. They go to infinity. Those are irrational. So that's the definition. So now, what are some tricks to remember, identify rational or irrational? So what I think is easiest is to think about the one that's called irrational because there's less categories of those. So irrational, we just said, is pi. Why? Because there's no pattern and it goes to infinity. No pattern goes to infinity. Sorry, I'm abbreviating there. I'm having a tough time. This pen is really hard to write with. The other thing is the square root of things that are yucky, which we would call rectangles. The square root of yucky stuff. Everything else is considered to be irrational. That's supposed to say everything. All right, so let's do it. So we're going to sort here the rational and irrational numbers. All right, so we have the square root of 25, which we know is a nice perfect square of 5. That would fall under the category of everything else. Number 1, rational. Number 2, checking our categories of rational versus irrational. Is it pi? No. Is it a square root of something that's yucky? That's a rectangle? No. So 3.5 is considered to be rational. Number 3, is it pi? No. Is it a square root of a rectangle? Is this a rectangle? Uh-huh. It's a 1 by 10 or a 2 by 5 rectangle. Definitely not a square. So irrational. That would be an irrational number. Number 4. Is it pi? No. Is it a square root of a rectangle? No. It's not even a square root. In fact, check it out. It's actually a fraction. And by definition, all fractions are considered to be rational. Fractions, by definition, are rational numbers. Number 5, is it pi? No. Is it a square root of a rectangle? No. So it would be a rational number. In fact, this would end up turning into -3/2. So there's our fraction. Rational. Number 6, is it pi? Yes. There we go. That means it is a non-repeating. Means it does not repeat. Does not stop, goes to infinity, super yucky decimal. So by definition, irrational. Number 7 rather, sorry. Is there a pattern? I see a pattern. So this by definition is a repeating decimal. And in math, we would consider that kind of a nice decimal. So that is definitely rational. There's a nice pattern there. Rational. Irrational is only when we have those yucky decimals. And number 8, by definition, that is a fraction. Boom! We got another rational number. So check it out. Scan it, scan it, scan it. Do you have an understanding of rational versus irrational? So the beauty of today's lesson is you do not have to show any work for anything, so that's super duper fun. But you do have to be able to understand the vocabulary and the definition of these. All right, so moving on to this page. So I'm going to do this page, and then you're going to try the next two. Reminder that irrational is the one that we should look for first. We're simply looking for pi and the square root of rectangles. All right, here we go. This is this rectangle. It's a 1 by 3 rectangle. Cannot be a square. Irrational. Next one. 4 1/5 really turns into 21/5 because we'd multiply here is 20 and we'd add the top. You learned that in elementary school. So 21/5. That is a fraction by definition, rational. The next one, the square root of 100 makes a nice beautiful square of 10. And that becomes 10 over 1. So we would say rational. Next one, 9 can be turned into 9 over 1. We would say rational. So really, as you observe, you'll notice there's a lot more R's than there are I's. Rational is a pretty common answer. Square root of 64 really is an 8 by 8 square, which really turns into 8 over 1. So by definition, it is a rational number. This next one, I think I accidentally moved the decimal here, but 7.35 is a decimal. No biggie. That's a nice decimal. We call that in math a terminating decimal, which means it stops. That's rational. It's nice. It's short. It's not yucky. The next one, we say that it is a integer over 1, which we get rational. And the last one, it is a integer or a whole number over 1, we would say rational. And again, the only one on the entire page here that wasn't rational was this one. And the only standard it was is that it's a square root of a square root of a rectangle. It's kind of yucky decimal. All right, we're at the 9-minute mark. What I'd like you to do is try these 8. See if you can identify rational, irrational, and I'll go over it. So you should be pausing the video at this time and giving those a shot. Okay, so you should have been coming back from pausing the video and giving these a shot now. Let's see how you did. Again, we are looking for irrational, we're simply looking for any number that is pi or a yucky square root or a yucky rectangle. Let's do it. Is that pi? No. Is it a square root that's yucky or that's a rectangle? No, it's not even a square root, so that's rational. Next one, is that pi? No. Is it a square root of something that's yucky? Not a square root. Rational. Next one, is it pi? No. Is it a square root of a rectangle? 21 is 1 times 21 or 3 times 7. Definitely a rectangle. This one is irrational. Next one, is it pi? No. Is it a square root of a rectangle? Not a square root. Rational. Again, you'll notice there's so many more R's. Next row, let's see how you did grading your paper. I'm going to go fast because you should have tried these. This is 9, rational. Next one, is that pi? Irrational. Next one, let's get it out of jail, would be positive 1/2. Remember, we're just looking for the distance from 0, so it has to be positive. And that, by definition, is rational because it's a fraction. Next one, is that pi? No. Is the square root of a rectangle? No, it's not even a square root. Therefore, it's rational. So the only two on this entire page that were irrational, grading your paper, should be the square root of a rectangle, 21, and, oh boy, my highlighter's not working here. Not sure what's going on. And pi, those two. Everything else can be turned into a fraction. Boom, last page of the day. Let's do it. We're at 10 minutes. I'd like you to try these 8. Pause the video, see how you do. Just simply write R or I, and you got this. All right, you should be unpausing that video. Let's see how you did. Again, when we are assessing these, we're really just wanting to know which ones are irrational, and then everything else by default is rational. So pi and the square root of rectangles. So first one, is that pi? No. Is it a square root of rectangle? No. Rational. Next one, I'm going to go fast because you should have tried these on your own. Is that pi? No. Is it a square root of a rectangle? Not even a square root. It's rational. Next one, is that pi? No. Is it this a square root of rectangle? 27 is 1 times 27 or 3 times 9. Definitely irrational. That's a rectangle, not a perfect square. Next one. 8 is like 8/1. That's a fraction. That's rational. Next one, we got a nice, beautiful pattern here. Rational. We like those kind of decimals. They're pretty. As math teachers, we like them. Next one, square root of 36 is really 6. Boom, that's rational because that can be turned into a fraction. Next one, that is a fraction. Rational. Next one, repeating decimals are beautiful. Rational. So as we scan this entire page, we can see that the only one that turned out to be irrational was the square root of a rectangle. That was it. It's just that and pi. Everything else is an R. So when in doubt, always assume R. So our summary for today's work basically was the difference between rational numbers and irrational numbers. Essentially, what I talked to you about in that work was that we're talking about pi and the square root of rectangles. And that is the only thing you really need to know. And those yucky decimals that don't stop, don't repeat, and so on. Everything else is on this side. Everything else is rational. That's it for today. Have a glorious night. Nice job. And make sure you understand rational versus irrational. Good.